Let R be the domain of the predicate variable x. So let's say we have p of x, x is a real number, x is a real number, or x belongs to a set of real numbers. X belongs to a set of real numbers. Then which of the following are true and which are false? Give counter examples for the statements that are false. So for the first statement, we have x greater than 2 implies x greater than 1. Now, if a statement is true, if a statement is always true, that means we can find a counter example for that statement. So if you want to quantify this, we can write the A as for all x, p of x is such that x is greater than 2 implies x is greater than 1. And we have x belonging to the real numbers. Now if this is true, then we cannot find a counter example. So we know that for all real numbers, if any real number is greater than 2, it means that number is automatically greater than 1. So this statement, this universal quantification is always true. Now for the B aspect, we have for all x belonging to the real numbers, p of x is such that if x is greater than 2, then x squared is greater than 4. If x is greater than 2, then x squared is greater than 4. Now, this statement is not always going to be true. This statement is not always going to be true because we have some values that are less than 2. But if you square them, you get a number greater than 4. For instance, if you take -5, -5 is less than 2. But -5 squared is greater than 4 because 25 is greater than 4. Hence, this statement is false. This statement is false. That's why we are able to find a counter example for it. Then C, x squared greater than 4 implies x is greater than 2. X squared greater than 4 implies x is greater than 2. So we have for all x belonging to the real numbers, then we have p of x. P of x is such that x squared greater than 4, x squared greater than 4 implies x is greater than 2. If you analyze this carefully, you realize that the converse of B is C. This statement is also false because -5 squared is greater than 4, but -5 is not greater than 2. So this statement is also false. Then we have also the D. The D. We are saying that for all real numbers, if x squared is greater than 4, for all real numbers, x squared is greater than 4 if and only if the absolute value of x is greater than 2. We can interpret this as x is greater than negative x is greater than 2, or x is greater than 2. Now this can be rewritten as, if you simplify this with your knowledge in inequalities, you get x is less than negative 2, or x is greater than 2. So we are saying that for all x squared is greater than 4 if and only if x is less than negative 2, or x is greater than 2. So this statement is also true.